Hi friends, welcome to the lecture. Today we will see what is a system of linear equations. System of linear equations. Suppose we have m linear equations with n variables, with n variables x1, x2, x2 so on, xn. That is, we have m linear equations with n variables which are nothing but x1, x2 up to so on, xn. These m linear equations are a11 x1 plus a12 x2 plus up to so on a1n xn, which is equal to b1. This is the first one. Similarly, a21 x1 plus a22 x2 plus up to so on a2n xn is equal to b2, and so on am1 x1 plus am2 x2 plus up to so on amn xn is equal to bm. These are the m linear equations with n variables. Now write these equations in matrix form. In matrix form, we get a11, a12 up to so on a1n, a21, a22 up to so on a2n, am1, am2 and amn into x1, x2, xn, and which is nothing but b1, b2 and bm, which is nothing but a11 x1 plus a12 x2 plus up to so on a1n xn will be equal to b1 by matrix multiplication. This matrix is of order m cross n. This is a matrix of order m cross 1, and it is a matrix of order m cross 1. Now let us take this matrix as a, which implies ax is equal to b, where a is equal to a11, a12 up to so on a1n, a21, a22 up to so on a2n, and am1, am2 and up to so on amn. This is the matrix A. X equal to x1, x2 to so on xn, and B is equal to b1, b2 to so on b. Therefore, these m linear equations we can write it in a matrix form. Matrix form Ax will be equal to b. Now we have to see what is a homogeneous system of linear equation and non-homogeneous system of linear equations. Homogeneous and non-homogeneous system of linear equations. Okay. Now, a system of equations of the form of the form ax equal to b, ax equal to b, where b is not equal to 0, is called a non-homogeneous system of non-homogeneous system of linear equations. System of linear equations. Okay. Similarly, a system of the form ax equal to 0, that is here value of this b is 0, is called homogeneous system of linear equation. Homogeneous system of equations. Okay. Now let us see what is a consistent and inconsistent. Consistent and inconsistent system of equation. System of equations. A system of equation, a system of equations having one or more solutions is called a consistent system of equation. System of equations, and a system of a system of equation having no solution, that is there is no solution, is called inconsistent system of equations. Okay. Those system of equations having one or more solution is called a consistent system of equations, and a system of equations having no solution. If there is no solution for a given system of equation, then we can say that the given system of equation is a inconsistent. Okay. Now, how to find out the solution of a system of linear equations? Solution of system of linear equations using or solution of a system of linear equations reducing in solution of system of linear equations by reducing in echelon form. Okay. Now here we have to see how to find out the solution of a given system of linear equation. Let us suppose that we have given that a system of m linear equations with n variables. Let we have a system of m linear equations with n variables. With n variables, that is a11x1 plus a12x2 plus up to so on a1n xn is equal to b1, a21x1 plus a22x2 plus up to so on a2n xn is equal to b2, and so on am1 x1 plus am2 x2 plus up to so on AMNXN is equal to BM. Now, if we can write this in a matrix form, then we get A11, A12, up to so on, A1N, A21, A22, A2N, AM1, AM2, and up to so on, AM1 into X1, X2, up to so on, Xn, and which is nothing but B1, B2, that is, it is of the form Ax equal to B, where A is nothing but a matrix of order M cross Z, and is called a coefficient matrix. Coefficient matrix. Okay, and capital X equal to, it is a matrix of order n cross 1. It contains n variables in a column vector, and it is called a matrix of a column matrix, a column matrix of unknowns, that is variables, a matrix of unknowns. Okay, and this one is called a column matrix. It is a matrix of order m cross 1, and it is called a column matrix of constants. We don't know what is the value of these m constants. Okay, now let C be a matrix which is nothing but A, then B, which is nothing but A11, A12, up to so on, A1N, A21, A22, up to so on, A2N, AM1, AM2, and so on, AMN into matrix B. B is nothing but B1, B2, up to so on, Bn. B1, B2, up to so on, Bn. And where the C is called augmented matrix. This type of matrices are called augmented matrices. Okay. Now the rank of a matrix C is rank of a matrix C cannot be less than the rank of the matrix A. Since every submatrix of a matrix A, this one is nothing but the matrix A, and this total is nothing but the augmented matrix C. Therefore, if we find out the rank of the matrix C, which cannot be less than the rank of the matrix, which cannot be less than the rank of the matrix A, since every submatrix of a matrix A is again a submatrix of a matrix C. Therefore, rank of matrix C cannot be less than the rank of the matrix A. Okay. Now we have to see the criteria to find out the solution of a homogeneous and non-homogeneous system of linear equation. Criteria for a solution of system of non-homogeneous linear equations. That is, how will you find out how many solutions will be possible for the given non-homogeneous system of linear equations. Okay. Now, first one, if rank of matrix C is not equal to rank of matrix A. If rank of matrix C is not equal to rank of, in previous steps we say that the rank of a matrix C cannot be less than the rank of a matrix A. But if rank of C is not equal to rank of A, then the system is inconsistent. Is inconsistent. Okay. As system is inconsistent, then by the definition of system of inconsistent system of equation, the given system has no solution, which implies the given system has no solutions. Okay. Now after that, if rank of matrix C is equal to rank of matrix A, and rank of matrix A is equal to number of unknowns, that is x1, x2 up to so on xn unknowns, then the system has unique solution. Has unique solution. Okay. Now the third possibility is if rank of C, rank of matrix C, that is augmented matrix, is equal to rank of our given matrix A, rank of A, but which is less than the number of unknowns. Okay. As the rank is less than the number of unknowns, then the system has infinite number of solutions. Infinite number of solutions. Okay, this is the criteria for a solution of a non-homogeneous system of linear equations. Similarly, we have to see the criteria for the homogeneous solution for the homogeneous system of linear equations. Criteria for a system of homogeneous linear equations. Now, the homogeneous system of linear equations, the homogeneous system of linear equations have either a trivial means that is the unique solution, or it has infinite number of solutions. Infinite number of solutions. Now we have to see when the given system of linear equation, homogeneous system of linear equation has a unique solution and when it has a infinite number of solutions. First one is if rank of A is equal, rank of matrix A is equal to n, where n are nothing but the number of unknowns in the given system of linear equation, then the system has unique solution. Okay. And if rank of matrix A is less than n, where n are the number of unknowns, then the system has infinite number of solutions. System has infinite number of solutions. Okay. Now we have to see one example depending on this concept. Solve the following linear system of equations, which is nothing but x plus y plus z is equal to minus 3. 3x plus y minus 2z is equal to minus 2. 2x plus 4y plus 7z is equal to 7. Now we have to find out the number of, this is as minus 3, minus 2 and 7 are non-zero, then the given system of linear equation is a non-homogeneous system of linear equations. Now we have to find out the number of solutions for this system of linear equations. First we have to see whether the solution exists or not, that is it is a inconsistent system of equation or consistent system of equation. Now, first write these linear equations in matrix form. Therefore, which is nothing but 1, 1, 1, 3, 1 minus 2, 2, 4, 7, and these are the x, y, z, and which is equal to minus 3, minus 2, 7. So this one is the, it's a matrix representation. Okay, where A is nothing but this matrix, X is nothing but this one, and B is nothing but this 3 cross 1 matrix. Okay, now it's a, now we have to first find out its augmented matrix C. Let C be its augmented matrix. Okay, as C is an augmented matrix, then C is nothing but C equal to 1, 1, 1, 3, 1 minus 2, 2, 4, 7, and B is nothing but minus 3, minus 2, minus 7. Sorry, 7. Okay, so this one is the our augmented matrix from a given system of linear equations. Now we have to reduce it into a echelon form. Let us change row R2 to R2 is changing to R2 minus 3R1. That is, here we have to make this entry will be equal to 0. And similarly, R3 is changing to R3 minus 2R1. Okay, then we get this augmented matrix C now becomes 1, 1, 1. First one is as it is. Okay, similarly here minus 3 is as it is. Now we have to subtract. Now we have to subtract this, subtracting R3 minus 2R1. That is 3 minus 3 into 1. 3 minus 3 into 1 is nothing but 3. 3 minus 3 is 0. Okay. Similarly, 1 minus 3 minus 2 minus 2 minus 3 minus 5. Here is minus 2 and this one is the minus 5. Now here minus 2. Here we multiply this by minus, multiply this by 3. Minus 3 into 3, minus 9. And now we have to subtract from this minus 2. Minus 2 plus 9 is nothing but 7. Okay. Now, R3 minus 2 times R1, it is nothing but 0. 4 minus 2, 2. 7 minus 2, 5. Therefore, 0, 2, 5, and 7. Now we have to multiply this by 2. 2 into 3, 6. 7 minus of minus 6 is nothing but 7 plus 6, which is equal to 30. Okay. Now, change this third row. R3 is changing to R3 plus R2, which implies matrix C is nothing but 1, 1, 1 minus 3. 0 minus 2 minus 5, 7 as it is. Now we have to add this to this. 2 minus 2, 0. 5 minus 5, 0. 13 plus 7, 20. Now here this is the augmented matrix C, in which this 3 cross 3 matrix is a matrix A. Therefore, rank of matrix C is equal to 3 since it has 3 non-zero rows. Therefore, rank of this matrix C is equal to 3 and rank of matrix A is equal to, there are only 2 non-zero rows. That is, it has only 2 linearly independent row vectors. Therefore, rank of this matrix A is equal to 2. And so here, rank of C, that is rank of augmented matrix, is not equal to our rank of matrix A. And in solution of system of non-homogeneous linear equation, first condition says that if rank of a matrix C, augmented matrix C, is not equal to rank of A, then the given system has no solution. System has no solution. Okay. In this way, we can find out the number of solutions of any system of linear equations by homogeneous and non-homogeneous method. Okay. Thank you for watching the lecture.